Good afternoon. Just a little bit of history about myself. If you pull out your phone today and you have a messaging service, then you write a text. You have a text field up there and your keyboard, and in between you have something like hey, hello, good, and you tap the word good, then you get the next word day, morning, evening, and you tap the word evening, then you wrote two words with two taps instead of typing the keyboard. This kind of next word prediction was invented by me. So it's in most of the phones today. We sold the technology to Nokia. We were a part of the Symbian Series 60 operation system, and we scaled the technology to 72 languages on device. What are we doing today? We are active along three different axes, namely health, mobility, and finance. So that we are working really cross-industry with one single platform. We understand structured data, images, as well as text. And our system runs in the cloud as well as on phones or in cars offline. And so from this perspective, I want to give you some insights about how you can use multimodality across different industries to really apply AI. So let me get straight to the end of the talk. What I want to have you taking home as a message is the three topics I'm concerned with today, namely how can we reduce the cost per AI experiment. We are really in touch with many companies here in Germany, really bringing AI to their industries. Their problem is how can I prioritize my AI experience to make something more efficient within the corporation, and how do I understand how much money I can spend to get what kind of result. So this kind of prioritization really implies the cost per experiment that I do, and we plan to reduce the cost per experiment. Second thing is whenever you replace a workflow within a company, then ideally you also introduce a data loop. So you really want to take all of the learnings that a process makes and the errors that you correct really feed back into the engine so that you basically can get the engine learning while you implemented that in your company. And the third thing is our promise is that whenever you combine data modalities like text and image, then you will get performance and quality gains. So what we do is we understand text very deeply. For example, here you see how we understand medical publications. So the machine was understanding that, here is a laser, is really understanding that aluminum chloride, which you have in your antiperspirants, is inducing learning and memory dysfunctions, which is classified as a disease, like Alzheimer's disease. So it's really understanding a pretty complex sentence in a publication. We can do the same thing across images, building relations across stuff that you extracted from images, or even structured data like canvas data or movement data from your smartphone. Whenever we extract these entities and their relations from the structured or unstructured data, we can build a so-called knowledge graph to understand what the world that the data is actually reflecting is keeping up. And so reading text across, for example, automotive documents, you see here, all of that is basically moving forward components in a motor. These are the braking components, and it automatically extracted force as something that is actually connecting these two. And that's kind of an emerging knowledge that you gain from reading lots and lots of texts. One of the things that we really found out that work very well is whenever you actually combine two technologies. So we are a text company by nature, but we also invested in understanding images. So one of the things that we did is we combined a deep learning algorithm for understanding the layout information of documents and combined that with the text analysis to really win the Allianz Hackathon last year to extract information not only from the text that is in the documents, but also the position within the document. So that's one example of multimodality. When it comes to cars, then one of the things that we see in the user interface is that the chatbots or Cortanas that you have in the car become smarter and smarter. They really establish one of the values for a car. Whenever you're sitting in, when it's a self-driving car, then most of the interaction that you will have in the future will be based on a dialogue system. So one of the things that we see is that basically this interaction has to get more meaningful. We have heard it via Chris Bose and Peter just on the main stage that the chatbots today are not very intelligent. They don't know what they are talking about. It's more or less something like a reflex where people write text that you can talk about, but really the chat is not understanding what it is talking about. So that, in my eyes, will be one of the next steps. When you look at, for example, Siri and Cortana, they are an isolated system. They don't have access to the car's states or the data of the car, so they cannot establish many of these semantic kind of data sources and talk about that. And so if you have a convergent representational framework, then you can bring these two together. How does that work? Basically, this is what we've built for a German car manufacturer. You can analyze the structured data within a car or the smartphone. You can predict what the user will do next within the car or with their smartphone. We had these predictive interfaces for years in smartphones. We have built a general framework for understanding what will happen next in the user interface. A second thing that we've built is a question answering system that actually can explain the functionalities of the car. These are two different projects, but if you combine these two data modalities, namely structured data as well as text, and bring them into correspondence within, for example, a knowledge graph, then you have this kind of multimodality where actually you cannot only ask the car, what is that lamp with a gas station on it? That would be a text-based question. But you could also ask what light is lighting up there. So the light that is lighting up is not referencing to something that the text-based system can understand, but the car itself has kind of a knowledge about its states, for example, that it's running low on gas. So this kind of state can be mapped to something linguistic, and suddenly the car can talk about itself. In linguistics, we call this referential semantics, and this is basically the key critique that people on the main stage had, that a chatbot cannot talk about something that is happening in the real world. In robotics, we would call this embodiment, so that if you have a robot that has sensor data and can reason about the outer world, this is something that is approaching more towards a real artificial intelligence. So what we're building here with the predictive layer, analyzing the states and the description, structural description of a car, and mapping this to the linguistics, that is, I think, the way towards building chatbots that actually understand what they are talking about. A second thing in the automotive industry is you not only have the canvas data, but you have the user behavior, you have external context, like all of the sensors that are looking out of the car, plus you have the different interaction schemes that you can have with the user. And the car manufacturers right now, they are trying to source different innovations which are predictive or AI-based, but whenever you see the amount of data that you can get here in terms of dimensionality, how many different factors of the outer world can I actually use to predict the user or be assistive, and combine that with what you actually want to articulate on what kind of interface, like talking or showing it or switching on something, then you have a combinatorial explosion. So all of these experiments that you can do, basically, they cost you something, and you want to bring down the cost of generating a functionality based on AI. So if you have a convergent knowledge graph that is combining this kind of structured data as well as the different user interfaces, then you get to a point where you easily can create more and more value based on one single platform. So that's also one of the main points, I think. We have seen that in the talk before. Yes, we know that chatbots work and they are valuable, but scaling them towards really covering more and more knowledge about something is one of the things that is really a matter of today. So it's not really bringing the chatbot into a value proposition, but really scaling it and mapping it to the reality, what people are actually talking about. And the second thing is, how do I create active components that can predict or be assistive. So we make all of these examples here, which are real studies about data that we see in the world. For example, that food and music actually really correlate. So bringing this kind of predictive analytics to a platform like a car will be actually pretty expensive. If you have the idea, okay, I'm looking at your Spotify data, for example, can I predict from that whether it's you're more a fan of Italian food or Japanese food? So you wouldn't dare, as a designer, to invest in a POC or something like that to actually get this result. But if the cost of an experiment to do so, because you have a convergent network, is very low, then you can simply try that out on your crowdsourced data. Yeah, the second thing is whenever we are building systems, and we had that through the day, also with Luminoso, that you have to adapt the knowledge that you can extract for a domain, let's say automotive, the cost for training it to the context that you're talking about, a car or a hospital or an insurance and so on. This kind of cost has to get down because you have to adapt to the domain. So we did an experiment here. Whenever you have a company recognizer in text, you want to understand this is a company in text, like Apple or IBM or something like that, and you train that on news, then it's really bad on medical text and vice versa. So if a company is selling you a general kind of recognizer for companies, it's probably not going to work on your text, although it's generally really of high value. So what you need is actually a system that can adapt to exactly your needs, your application scenario, your domain, or your industry. And bringing down this cost is also one thing that is very important when you really bring AI towards an industry or an application scenario. Exactly. So talking about data loops, we think, and that's also our experience with car manufacturers here in Germany, whenever you have a predictive model, then usually you have something that you're using from a cohort of cars that are in pre-production. They produce data. Then you can fit a computational model to do something, predict the user behavior, which is here in the middle. Then you can basically roll that out to a single car, and it will apply to a single user. It will adapt to one of the groups that you actually have established through the initial data set. And then whenever it adapts to a single user, you can crowdsource that back to the system so that you have an iterative way of learning from your audience through sourcing the data as well as fitting single user contexts. A second data loop that is also from the car manufacturer, whenever you actually design a part of the car, then you have this kind of form where you say, okay, the functionality of this part is such, it's connected to these parts, as well as whenever it breaks down, what is the probability and how do I fix it? This is a kind of engineering description of car parts. That is used for constructing cars before they actually go out on the market. But then when they are on the market, you have these kind of procedures that you use for actually repairing the cars. And basically you get a garage report afterwards so that somebody is writing, okay, I did this and that diagnostics, I found this and that is broken, and I exchanged this and that, right? And mapping these two languages together is a very important part when you're closing the data loop. So you have designed the car, basically, you get it out on the field and it gets repaired, and naturally you want to understand what kind of parts get broken through what kind of, let's say, environmental factors or heat or something like that, and you want to bring back this kind of information into your design process. So after sales and design will be connected. But in fact, these two groups really speak different languages, so you need kind of a machine translation between the engineer and the guy in the garage that is producing the reports. Finally, whenever you have an AI platform in your company and you used it to do a couple of different experiments there, and you have established a couple of workflows that really work, then our experience is whenever you have invested in here to understand a type of document that is describing your workflow, then you can reuse these resources for a different use case. And whenever you reuse your use cases, ideally even combined with the data loop, then the representation of what is going on in your company will get sharpened, and you can extend that to more and more use cases or workflows within your company. So you're bringing down basically the overall cost when you're establishing different AI parts within your company. So that's, I think, an important part when it comes to bringing AI to corporations. We see that here in Germany, that we have many industry companies that want to establish a chief digital officer, and he wants to establish AI, and how to grow really this kind of potential that you have from a TensorFlow workflow and deep learning, whatever kind of single solution, to really mature AI into your corporation. That's, I think, a very important next step in the industry. And so we think this kind of a multimodal platform is very helpful. So when you're looking at machine learning, that's just one of the pieces here. Then you have this kind of interactive training or closing the data loop. Plus, ideally, which is very often not the case, people don't actually evaluate their data. So whenever you have an established procedure of correcting something, then your problem is you don't actually know what your initial quality of your algorithm is. Then you establish some kind of machine learning, but you don't know what the difference is. How much better did I actually get? But you need that whenever you're actually establishing a data loop because you want to see how your overall performance is increasing. So it's not about, you know, getting TensorFlow and doing some kind of deep learning. You need the whole layer here of working with your machine learning models, doing a versioning with them, having different histories and so on, to actually really build a sustainable AI module in your company. This is how our system looks like. You can basically visually combine different modules. You can analyze documents and structured data, as well as medical data and structured data. just as a little example, and a couple of hackathons and challenges we've won. And I still have 24 seconds. Thank you.